Hello everyone. So the plan for today is to talk about interest. Interest, not in the kind of interest that we have, but specifically interest in terms of money, right? Now, what is the idea of interest? Everything has a cost, right? So when we talk of money, money will also have a cost. For example, if I want to start a business, I do not have money of my own. What I would do is I'll go to a bank and I'll say, okay, you can lend me some money and I'll pay you back. Since the bank is giving me a commodity, they will charge a price for it. That is interest. So basically, the cost of money becomes interest. Now, interest can be charged in a couple of ways. It could be simple interest, or it could be compound interest, right? uh, Generally, when we look at SI and CI, simple interest, compound interest, uh, in terms of outrightly questions in exams or questions that when we practice, it is seen that simple interest is something that we are able to manage a lot more easily as compared to compound interest. Simple interest के question हो जाते हैं, compound interest में दिक्कत आती है. Primarily because two reasons. Number one, formula simple interest का बहुत simple है, compound interest का थोड़ा compound है ना. दूसरी बात, it is I think easier to understand the concept of simple interest versus the concept of compound interest. So how do these two things work? When I say simple interest, what is the idea of simple interest? First of all, now here my assumption is that we know the basics of SI CI and we will focus on the concept of CI more than SI for this video. So again, the words that will be used are the principal. This will be measured in rupees. This is the amount of money that we will start with. This might be invested, this might be borrowed. Then we'll have the rate, which will be in percent per annum. Annum means year. Y percent per annum or Y percent rate. When we talk of money, it is measured in rupees. The cost for money will also be measured in rupees. So I can either say that the cost of money is rupees 10 for every rupees 100, right? Or because the units are same, we can express it as a percentage, and therefore interest is calculated as a percentage for a period of a year. The third is time period, T, typically in years. And finally the amount. Amount is nothing but the principal plus interest. So this is the final sum of money that will be returned or I will get depending on whether I invested or I borrowed. So these are the four terms: principal, rate, time, and amount. Getting into the concept of simple and compound interest, how do these conceptually work? When I say simple interest, what is simple interest, or how is simple interest different from compound interest? Simple interest is simple, or as we would recall in school, that in simple interest the principal does not change. Interest is charged on the same amount. What is compound interest? Principal changes or interest on interest is charged. These are the statements that are made. Now, how do they work in practice? Suppose, in case of simple interest, what will happen? For all my calculations right now, I am using rate as 10% per annum. So if 100 rupees is invested, we will get 10%, 1/10, 10 rupees back. If 500 rupees is invested, we will get 50 rupees back and so on. Now suppose I go to the bank, this is the start of year 1, and I put in my bank rupees 5,000. What happens at the end of year 1? Since I have invested 5,000 in the bank is obliged to pay me interest. So in my account, in my passbook, it will show 5,000 rupees that I had invested plus the 500 rupees that would be the interest. 10% of 5,000. Now, since I am in the bank, what I do is I take out this 5,000 rupees with me. So, in the bank, again, this 5,000 rupees is left. So, at the start of year 2, I still have 5,000 in my account. And therefore, at the end of year 2, the bank will give me further 500 rupees. Again, at the end of year 2, I go to the bank. I take this 500 rupees with me. So again, 5,000 rupees is left. This kind of a transaction is simple interest. So in this case, every year, the interest that is paid is on the starting principal. There is no interest that is paid on the interest because whatever interest is accrued, I will be taking that out. What happens in the case of compound interest? Again, at the start of year 1, I invest 5,000 rupees. And therefore, at the end of year 1, the bank owes me 5,000 rupees that I had invested plus 500 rupees as the interest that the bank has to pay me. Now, what I'm saying is, at this point in time, I was out of town. So, I could not take the 500 rupees out of the bank. So, I know bank may छोड़ दिए. Now, what will happen at the end of the year 2? Year 2 जब शुरू हुआ, तो बैंक के पास मेरे 5,000 rupees as it is थे, plus 500 rupees interest that the bank was supposed to pay me. What will happen at the end of year 2? At the end of year 2, this 5,000 and the 500 rupees, ये तो as it is रहेगा ही बैंक में. Plus the bank will pay interest on this 5,000 rupees as 500. Plus now the bank also owes me this 500 rupees. So इस पे भी interest देना पड़ेगा. So they will give an extra interest of 50 rupees. So at the end of year 2, if I look in the case of compound interest, the interest that is accrued is 500 plus 500 plus 50. So I'm getting extra interest. This is the idea of compound interest. So in this case, what happens is we get interest on the interest that is accrued as well. So clearly, compound interest will give me higher interest after year 1. If I try to write the formulas for these two cases, the basic formula for simple interest is P into R into T upon 100, where P is the principal, R is the rate, T is the time. And how do we get this formula? Interest every year will be R% of P. How do we calculate R% of P? R upon 100 into P. This will happen in year 1. This will happen in year 2. This will happen in year 3. And so on. Total interest will be the sum of all of these. So if this happens T times, the total money that will have is R% of P, T times over. And therefore simple interest is R by 100 R% of the principal into T. Right? भाई ये तो हमें आता ही है. Further, if I want to calculate the amount in this case, I will add the simple interest that I have calculated using the formula to the principal to get the amount. In case of compound interest, we will in a bit derive this formula as well. But in case of compound interest, the basic formula is for amount, and amount is given by principal into 1 plus R upon 100 raised to power n, where P is the principal, R is the rate, n is the number of years. This formula is for amount, so if I have to calculate the compound interest from the amount, I will subtract the principal. So this becomes the net formula for interest. Now if we compare SI and CI, the basic formula in simple interest is for interest SI, The basic formula for compound interest is for amount. Amount in simple interest will be P plus SI. Here CI will be A minus P. SI remains same across all the years. CI keeps on increasing. After year 1, actually, if you are comparing year on year to year 3, there is a constant increase. But SI and CI will be the same for the first year. After the first year, CI will be greater than SI. Just a couple of quick questions on SI before we actually delve into CI. Trying to cover the broad range of questions. Please understand, SI is additive in nature. That is to say, if I am getting 50 rupees of simple interest in 1 year, I will get 50 rupees every year. And therefore, in 3 years, I get 150 rupees. In 4 years, I get 200 rupees and so on. So if you look at this question, it says, what is the simple interest earned on 6,000 rupees in 9 years? So principal is given, time is given. Rate of interest is 12% for the first 5 years and 15% for the next 4 years. So what can we do here? As we know, for simple interest, 90% of the questions can be solved using the formula itself. So I will say simple interest is simply equal to principal for the first 5 years. Rate is 12. So 12 into 5 upon 100. For the next 4 years, principal into rate into time upon 100. So 0, 0, 0, 0 cancel. 60 into 60, 3600 plus 60 into 3600. And therefore the interest that is due after 9 years will be 7,200 rupees. This is why we are solving the question again. Simple interest questions can almost certainly be solved by simply writing the formula. Or what I would have done was, I could have said, see, if I'm getting 12% for 1 year, in 2 years I'll get 12% plus 12%, 24%. In 3 years I'll get 12% of P, 12% of P, 12% of P, 36% of P. And therefore we can say in the first 5 years, we will get 12 into 5, 60% as interest. In the next 4 years, we will get 15 into 4, 60% as interest. So the total interest will be 120% of P. Principal is 60, so 120% of 6,000, sorry. Which will again come out to 7,200. Point being, simple interest is additive in nature. If the principal is same, I can add the rates. If the rate is constant, I can add the time and so on. Next question. A certain sum of money invested under SI. Also, when you're looking at the question of SIC in the exam, please be sure to first identify whether the question talks about SI or CI. Because obviously the answers will be different depending on what you're calculating. And the question has to specify whether it is SI or CI. If it does not specify, technically the answer cannot be determined. So here it says a certain sum of money invested under SI becomes 1,700 in 6 years. Becomes means, so if money was invested, after 6 years, the total money that is now due is 1,700. So basically, after 6 years, the amount is 1,700. And after 9 years, it becomes 1,880. We have to find the principal. What do we do here? So basically, we start with the principal. In the first 6 years, it amounts to 1,700. Over the next 3 years, it amounts to 1,880. So as I said, if it is a SI question, almost certainly it can be solved using formulas. So I write two formulas. Basically here we know the time, we know the amount. We do not know the principal and rate. So there are two variables. So I'll write two separate formulas. First I say, in the first case, simple interest will be amount minus principal. And this will be principal into rate into time upon 100. In the second case, amount minus principal is principal into rate into time upon 100. Divide the two equations. R will get cancelled out. We will get one equation in P, which we can solve to get the answer. Again, not the most efficient way of solving, but the formula for SI will give you the answer in case of simple interest. How do we actually solve this question? We solve this question using the properties of SI, and the most basic property of SI was simple interest remains the same across each year. Now, if I look at the amount increasing from the 6th to the 9th year, if I look at the amount increasing over these 3 years, I see that there is an increase of 180 rupees. This increase will be because of the interest. So I can say simple interest for 3 years is 180, which means simple interest for every year should be, because simple interest is same in each year, it should be 180 upon 3, which is 60 rupees. So now we know the simple interest for each year. The same logic will apply here as well. From the principal, we will get simple interest for 6 years and reach 1700 rupees. Since simple interest for 1 year is 60 rupees, simple interest for 6 years will be 60 into 6, 360. That means there is an increase of 360 rupees here. So the principal will come out to 1700 minus 360, which is 1440. And that simply becomes the answer. Simple interest is additive. It remains 1340, sorry, 1600 minus whatever. Simple interest is additive and it remains same every year. One more question. It says Amit has 6,000 rupees. 2/3 of it he invested a certain rate, remaining at 1% higher rate of interest. If Amit received 1,000 as total interest for 2 years, find the higher rate of interest. So 6,000 rupees, 2/3 means 4,000. This is invested at R%. The remaining 2,000 is invested at R plus 1%. Because of this, the interest that we are getting is 1,000 rupees for 2 years. We know the principal, we know the time, we know the simple interest. We just need to find out the rate. So we write the total interest 1,000 is equal to, in the first case, 4,000 at R% for 2 years and 2,000 at R plus 1% for 2 years. I have an equation in R. We can solve to get the answer. Now, when I say that simple interest is additive, what I can also do is I can use that concept to solve it without actually writing the equation. See, first of all, because simple interest for 2 years is 1,000 rupees, so simple interest for 1 year should be 500 rupees. Simple interest same in every year. Also, if I look at this, I am getting R% of 4,000. plus r% of 2000 plus 1% of 2000. 1% of 2000 will be 20, and this will be r% of 6000. So basically r% of 6000 plus 20 will be the 1 year's interest, which means r% of 6000 will be 480. Now what number should I multiply 6 with to get 48? Because 8 6 are 48, so r becomes 8. This actually could have been done orally as well. And therefore, the answer in this case, the higher rate of interest will be r plus 1 or 9%. Another common question, this is common to both SI and CI and across different exams, has been asked several times in different formats. Says a certain sum of money invested in the SI becomes 5 times in 7 years. In how many years will it become 25 times? Might just take a minute and try to solve this question. A certain sum of money becomes. So if I invest 1000 rupees, it will become 5000 rupees in 7 years. 1000 rupees now has to become 25,000 rupees. How many years will be required? So basically, I can assume a principle from which I know the amount in the first case. We know the number of years, we can find out the rate. Using that rate, we can find out the time for the second case. So what I'm saying is, suppose the principal that we are investing is 1000 rupees. In the first case, this has to become 5000 rupees amount in 7 years. So I can say that the simple interest will simply be 5000 minus 1000, which is 4000. So simple interest is equal to principal into rate into time of 100. We can find out the rate. This rate will be used for the second case, where I say principal is 1000 in t years. It has to become 25,000, 25 times, which means simple interest will be amount minus principal, which is 24,000. So simple interest is equal to interest into rate. Rate की वैल्यू यहाँ से आ जाएगी और टाइम हम निकाल लेंगे. Of course, this is not how to solve the question, but this is what technically happens in this question, right? How we solve it is using the concept of SI, where we say that SI remains same every year. So here, if I look at it, see, principal was 1000, amount was 5000, which means simple interest of 4000 in 7 years, according to the question. I have to go from 1000 rupees principal to 25,000 rupees amount, which means we need a simple interest of 24,000. In how many years will this happen? Every 7 years I will get 4,000 as interest. 4,000 to become 24,000 has to be repeated 6 times. 4,000 to 6 is 24. So the year also gets multiplied by this. And therefore the answer will be 42 years. In general, if I have to solve this question without exception, in case of SI, what we can do is we can generalize this by saying, suppose the question says a certain sum of money becomes X times in n years. In how many years will it be? Y times. The answer always will be y minus 1 amount minus principal upon amount minus principal into number of years. Without any exception, y minus 1 upon x minus 1 into n. right? These are concepts of simple interest. Moving on, compound interest. Compound interest, the formula is given by 1, so the amount is equal to principal into 1 plus r upon 100 raised to power n. Now my question is, where have you earlier read this expression 1 plus r upon 100? If you've done percentages, you would have come across the concept of multiplying factor. So if a value increases by 20%, it becomes 1 plus 20 upon 100 of itself. That is the idea of compound interest. So when I say that I am starting with the principal of 1000 rupees at a rate of 10%. What will happen after 1 year? Because the rate is 10%, I will get 10% of 1000 rupees, which means the value of 1000 will increase by 10%. And therefore, after 1 year, it will become 1000 into 1 plus 10 upon 100, which is 1100 rupees. In the next year, I will be paid interest on the entire thing that is accrued, the principal plus the interest that is there, and therefore this entire thing will increase by 10%. So, in the original value, we will have another multiplying factor, which will be 1 plus 10 upon 100. And every year this happens, we'll keep multiplying the multiplying factor, and therefore after n years, the final amount due will become principal into 1 plus r upon 100. This multiplying factor multiplied for every year, so into n, or raised to power n. That is how we reach the formula for compound interest, basically amount in compound interest. Once we know the amount, we can calculate the interest by subtracting the principal from the amount. Now, what I want you to do is make a set of calculations without using the formula, obviously. I am starting with the principal of 10,000 rupees. The rate is 10%. What I want you to do is, for a period of 4 years, 1, 2, 3, 4, we will try to find out CI for that year, compound interest for the nth year, amount at the end of that year, and total CI till that year. Right? These are the three things that we're trying to find out. Once we do that, we might see some patterns which we can use to solve questions. So if you will just take a minute and try to fill this table. So the first column that is to be filled is compound interest for that specific year. So compound interest for the first year alone, compound interest for the second year alone, compound interest for the third year alone, and so on. The second column, therefore, is the amount at the end of each year. What is the amount pending at the end of the first year? The amount at the end of the second year, total. And once you subtract principal from the amount, we will get the compound interest which has accrued for the entire duration till that point. So these are the three columns that we are trying to fill. For ease of calculation, I am taking rate as 10%. 10% of anything is simply multiplied by 1 by 10. So in the first year, what I am saying is, principal 10,000, rate 10%. So the compound interest will be 1/10 of 10,000 rupees. Because of this, the amount due will be 1,000 plus 10,000, 11,000. And the total compound interest would be 1,000 rupees till date. What happens in the second year? At the end of the first year, the amount due is 11,000 rupees. And therefore, in the second year, the interest that will be charged will be on that entire 11,000 rupees. So the interest will be 10% of 11,000. which will be 1100 rupees. 10% of this. Amount, I add the interest to the amount. So 12100. And if I subtract principal from your total compound interest, you get 2100. Year 3, 10% of this will be charged as interest. If I add it to the amount, 13310. 13310. Total interest 3310. Amount minus principal. Fourth year again, 10% of this is 1331. If we add it here, so 14641, which means total interest of 4641. So for the first column, I have taken 10% of the second column's value. Then I have added this interest to the amount to get the amount at the end of the year. Amount minus principal gives me total compound interest. Do we see any patterns here? Do we see any pattern here? The first two columns definitely show patterns or concept that is repeated, and they are related as well. So I get 3 points with respect to compound interest. Number 1, compound interest for each year increases, or rather better, wait a minute. Not this. First I'll start with compound interest for each year is R% of A at the end of previous year. Compound interest for the second year, for instance, 1100 was 10% of amount at the end of the first year. Compound interest of 1210 was 10% of this amount, and so on. Second amount at the end of each year increases by R%. 10,000 increased by 10% is 1100. 1100 increased by 10% is 12100. 12100 increased by 10% is 13310, and so on. Lastly, compound interest for each year increases by R% every year. Since the compound interest for each year is a certain part of this value, and this value is increasing by R%, this value will also increase by R%. 1000 increased by 10%, 1100. 1100 increased by 10%, 1210. 1210 increased by 10%, 1331. So without any exception, in case of compound interest, we can use these three identities for solving the question that we come across. Also, you will realize we have effectively calculated all the values for compound interest for 4 years without using this formula at all. So if you look at a few questions and applications, the question says, okay, this is unfortunately a question, a formula-based question. In what time will 2000 amount to 2662 at 10% per annum compound interest? Just write the formula. Amount principal into 1 plus R upon 100. R is 10%, sorry. Raised to power n. This becomes divided by 1331 upon 1000. This becomes 1 by 10. 11 upon 10. This is 11 upon 10 cube. So n will be equal to 3. If I am not able to solve using the formula, what I'll do is I'll use the property that I just talked about. So the amount has to increase by 10% every year. Sorry. 2000 increased by 10% will be 2200. 2200 increased by 10%, again 220 will get added. So 2420. इसका 10% 242. 2662. So it happens in 1 to 3 years. That is my answer. Even if I'm not able to fit in the formula, or I tend to forget formulas, does not matter. The basic concept of CI is that the amount and the compound interest for every year will increase by R% each year. For example, this question says a certain sum of money, compound interest, amounts to 2700 in 2 years and 3000 in 3 years. Find the rate percent. Again, because the amount is being mentioned, I can use the concept of I can use the formula as well to try and solve this. For example, if I say in the second case, after 3 years, amount 3000 is equal to principal into 1 plus R upon 100 raised to power 3. In the first case, 2700 P into 1 plus R upon 100 squared. If we divide the two, P will get cancelled. R square and cube will get cancelled. I'll get an equation in R and I can solve it. But a better approach is, see, the principal is becoming 2700 in the first 2 years. Over the next 1 year, this 2700 becomes 3000. So 300 rupees are being added. Right? So 300 becomes the interest for the third year. And we know that interest for every year is R% of the amount at the end of the previous year. So interest for the third year will be nothing but R% of this. So I write R% of 2700 is equal to 300. R is equal to 300 upon 27 or 100 upon 9. 11.11% becomes my answer. So the calculation, at least the steps for that calculation reduce drastically. And since I'm using a basic property, I'm more confident in attempting the question. Formula याद रखने की जरूरत नहीं, concept आता है मेरे को. Look at this question then. Now here the amount is not mentioned, and therefore using the formula kind of goes out of the window. It says if the rate of interest is 20%, then the rate of CI in the 96th year ratio of CI in the 96th year to the CI in the 97th year would be. Clearly, this is not a calculation that I will do using the formula because as it is 96, 97, I cannot calculate powers. Also, it does not talk about amount. Just talks about the compound interest. So how do we go about this question? There is only one property that I know that talks about compound, actually two properties, compound interest for each year. First is that compound interest of each year is R% of amount of the previous year. In this question, the amount is not being referred to. The second property for interest was compound interest increases by R% every year. So if the compound interest in the 96th year is 100 rupees, in the 97th year it will increase by R%. R is 20%. So increase 100 by 20%, 120. And therefore the ratio will be 100 upon 120 or 5 by 6. If you look at the question, it seems quite daunting, intimidating, whatever. But the answer is simply 100 upon 120. Like no calculation needed for which you have to run the pen. What if I ask you the ratio of compound interest for the 96th and the 98th year? So 96 years CI was 100. 97th year it became 120. 98th year it will increase by 20% again. 20% of 120 is 240, 24. This will become 144. So the ratio of the 96th year to the 98th year compound interest will be 100 upon 144, which is divided by 4, 25 by 36, or 5 by 6 square. So every time you move on to the next ratio, the same multiplier will get multiplied depending upon the rate. X1 into n was my answer. Here it says in how many years the sum become 8 times when it becomes double in 7 years. Please understand, in case of simple interest, the numbers do not matter in the sense that I will get an answer for integral answer probably for any set of numbers. Any value of xy will give me an answer, may not be integral, but there will be an answer for sure because SI is linear. In case of compound interest, the x and y corresponding typically have to be powers of each other. So it says sum of money doubles itself in 7 years. In how many years will it become 8 times? Now here I can say that every time I invest 1000 rupees in 7 years, it will become 2000 rupees. So if I invest 2000 rupees in 7 years, it will become 4000 rupees. If I invest 4000 rupees in 7 years, it will become 8000 rupees. So I think I have found a multiple of 8. Again, if I am trying to solve this and I try to write the formula, I will say 2000 amount is equal to 1000 principal into 1 plus r upon 100 raised to power 7, which gives me the value of 1 plus r upon 100 raised to power 7 as 2. We need an amount of 8000 from a principal of 1000, and we have to find out the time at the same rate. So 8 is equal to 1 plus r upon 100 raised to power t. Now I have to make this 2 as an 8 with the power. So I take the cube on both sides. Which means 8 will be equal to 1 plus r upon 100 raised to power 21. 1 plus r upon 100 raised to power 21 is equal to 1 plus r upon 100 raised to power t. Since the base is same, so t becomes 21. In terms of formula, this is how it plays out. But logically speaking, what I'm saying is, if I start with P in 7 years, it becomes 2P. If I forget the first part, in the next 7 years, this 2P should also double. That is what happens in compound interest. For the same period of time, the multiplier will be the same. So 2 to the 4P हो जाएगा. And if I forget all of this and say I'm starting from here, in 7 years this should double. So from P to 8P, I can go in 7 plus 7 plus 7, 21 years. So for a given period of time, the multiplier for the principal is same in case of compound interest. So if I say 1000 rupees become 1500 in 5 years, so 1.5 times. In the next 5 years, 1500 will become 1.5 times, 2250 and so on. Just look at this question. This has a concept of multiplying factor and then what we just did. Hmm. If the sum of money trebles itself in 6 years, in how many years will it increase by 26% under CA? First of all, what is an increase of by 2600%? If principal, if the principal has to increase by 2600%, what will be the amount? The amount will be P into 1 plus 2600%, 2600 upon 100, multiplying factor, will be 27P. So P increasing by 2600P means it has to become 27P. And trebles means becomes 3 times. So P becomes 3 times in 6 years. 3P will in the next 6 years become 9P. And that 9P will get multiplied by 3 in the next 6 years and become 27P. So if a money trebles, sum of money trebles in 6 years, an increase of 2600% or 27 times will happen in 6 plus 6 plus 6, 18 years. Look at this question. This is something that you might actually end up using in life. It says, what are the minimum complete years required so that an amount doubles itself when invested under CI for 10 at 10% per annum? So there is a sum of money that has been invested under CI at 10% per annum. In how many years will it double itself? So for this we have something called as the rule of 72. It is an empirical rule, and it says for compound interest, P to double R into N is equal to 72 roughly. So at the rate of R%, a principal will double in n years such that R into N will be 72. And therefore here, because the rate is 10%, I can say 10N is equal to 72. So N will be approximately 7.2. So if I invest a certain sum of money at 10% compound interest, in about 7.2 years, it will double itself. And therefore, if the question is complete years, it might not double in 7, but in 8 it would have definitely doubled. So 8 complete years will be required. But empirically, in practical situations as well, we can assume that for an amount to double at compound interest, R into N, where R is the rate, N is the number of years, is 72. The rule of 72. Now, till now, when we're looking at questions, we were talking of compounded annually. There could also be a case where the principal, the compound interest not compounded annually. For example, if I say there is half yearly compounding, what does this mean? Half yearly compounding means interest is paid out every 6 months. What is the effect that this will have? First of all, whatever rate that we have, suppose the rate is 20% per annum. For half a year, it will be half of 20%, 10%. Secondly, in 1 year, interest will be paid out twice. So if I say that I have a principal of 1000 rupees, rate of 20% per annum, any rate that is mentioned in the question or otherwise is always per annum, and I am looking at a time of 1 year. If simple interest is given out half yearly, how will the value of simple interest change? If I look at simple interest, yearly simple interest will be principal into rate into time upon 100. Does not. So this is the yearly interest. If simple interest is being paid half yearly, the rate will become half. But now in 1 year, interest will be paid twice. Technically, no change will happen. So when we say that the interest is paid more frequently, the effect will only happen in compound interest. And what will be the effect? If we look at yearly compounding, you will realize that the principal of 1,000 rupees will increase by 20% and become 1,200 rupees. Compound interest of 200. What about half yearly compounding? 1,000 rupees in the first 6 months will increase by 10% only. Will become 1,100. Over the next 6 months, this will increase by 10%. 10% of 1,100 is 110. So this will become 1,210. So instead of 200, I am getting interest is 210, which is 21%. Because some interest was calculated earlier, we will get interest on that and therefore the effective interest will increase. So the more frequent compounding happens, the more frequent or the higher the interest would be. Two things here. Number one, if I want to calculate the effective rate, you will realize that this is nothing but successive percentage change. One value increasing twice. And therefore, the effective rate in case of compound interest can be written using the AB principle 10 plus 10 plus 10 into 10 upon 100. So, if the question says half yearly compounding, rate 20%, I can calculate the effective rate for the year as 21% and then use it like annual compounding. Or if I'm writing the formula, what are the changes that happen in the formula? Every single time, R gets divided by the number of times interest is paid in a year. T gets multiplied by the number of times interest is paid in a year. So in this case, I'll write amount is equal to principal into 1 plus R by 2 upon 100 raised to 2t. Because half yearly compounding. If it was quarterly compounding, we would write 4 and 4. Monthly compounding, we would write 12 and 12. Right? So basically, when we look at simple interest, it is additive in nature. We calculate a principal, we calculate a percentage and keep adding to the total value. Compound interest is multiplicative in nature, and every time the multiplying factor gets multiplied to reach the next value. Clearly, compound interest will have a more profound effect on the interest, and therefore should be preferred when you are making the investment decisions. While you are making your decisions for the exam, refrain from being stuck to the formula for compound interest. Use the basic understanding and identities for CI. It will help you solve questions better and faster. Right? So I think that is mostly what I have to share today. Very soon we'll come up with some questions and we can have a sort of a discussion on questions as well. Until then, make sure you go through compound interest again without using the formula. Try to use the identities or the concept of CI to solve questions, right? That is pretty much what I have to say. Thank you very much for your time and I'll see you soon. Take care, bye.